Thank you for joining this session. I am pleased to be here, and we are going to see today building secure and flexible multi-cloud image with multi-boot mode, a comprehensive CI/CD approach. But before starting, I'd like to present myself. So, who I am? I am a Brazilian expat living in Poland. I have about 70 years of experience in IT, and my main experience relies on being a developer specialist with Fox automation in infra and cloud. So in this session, what will you see? We will see hints of the code, and we will see why you choose the approach, our solution, some overview of the CI, and the reason behind of all of this approach. So the CI/CD overview. So we are going to see what it stands for CI/CD. For those that don't know, CI/CD stands for continuous integration, and CD stands for or continuous delivery or deployment. Depends on which kind of product do you have. So for CI is usually when you have automated builds, automated testing, you want early detection, you have code qualities. And continuous delivery is like when you have automated deployment, you want to reduce the time to the market. So you build and you promote this to the marketplace, for example, and this you help to have a better delivery. And deployment, you have a commit, you push, and you build and you deploy to production services. So you have an efficient and feedback loop. In our case, in our approach, we just need CI and the CD for continuous delivery because we are not deploying anything to the customer in the research connector. So in the user expectation, the user expect a reliable and available system that you can have frequent updates. It's easier to fix bug and it's very fast to fix the bug. Is constant in the user experience, has security, and you can has privacy, and you can also see the logs, so you can see the transparency, you can see what's happening in the jobs. Has nice and features. So that's what the user usually expect from a CI/CD system. So our context is the Research Connector product. So the Research Connector product is a piece of inside of the Zero Trust Network access suite. So Cisco has this product to help the customer to guarantee zero trust in the network. So you're allowing security features from access to internal websites or systems or any endpoint. So, and the research connectors works as a kind of tunnel or proxy/VPN, and is deployed in the same subnet where the private app you want to give access to the user in his smartphone or his computer. And to access is not via directly, but via the suite of Zero Trust, and then using the connect research to access. So because the customer can have different clouds and be different data centers, so we, for our own reasons, we want to support different clouds. So that's why we want to support Azure, Google, AWS, and so on and so on, VMware and OpenStack, whatever is where the customer is, we want to be there because it's in our interest to be there. So that's why we want to have a product that is multi-cloud. And multi-boot mode because the clouds may support TPM, may support security boot, and we want to have the safest features available in each cloud. So that's why we want to have different boot. But also internally, we need to disable the security boot for internal and reason or troubleshooting and debugging. So that's why we need to build different boot modes. And we have a strategy on building different stages. So we are creating harden. So we get from the supplier, for example, Canonical, we get Ubuntu. We harden where we install and configure the OS with security checks, mandatory regulation, anything that's necessary to create a secure and hardened OS. And that OS we use in the product and in our own internal builds, runners, internal services, anything that we need to use. Then with the hardened image, we create a baseline product where we create partitions, make OS upgrades with for example, apt-get upgrade, apt-get update, anything that will update some software internally, and that will get latest version with everything, with any CVs fixed and so on. And with the base image, then we use as the input to create the boot mode. So use as base, and then we install Cisco proprietaries code. That's like, for example, the Connect, any other software that makes the product what's the product. And enable, disable the boot modes, or selecting which boot modes to enable in that VM image. And we have a code overlap. So we don't want to copy and paste code all over the place. We want to share the code. For example, to create the product is similar code to build uh, the the product. So instead to have one file for Azure, one file for VMware, one file for AWS, and so on, we have a build a script that will be similar all across to the cloud. So it's easier to maintain, but it's also on the other hand is tricky. On the other hand, it's tricky because if you change one line, and you can break something that you are not even thinking. So you are changing something for thinking in change for AWS, but then you, without knowing, you break something in Azure. So we need to double check all things that you support. So every time that you support a new boot mode or a new cloud, this increases the pain. So as much you are increasing the support, you're increasing also the pain. So this is very critical for our developers to support, and very painful as well. So because that, we came with the approach that is supporting different stages in different repos. So every stage will be a repo. So the harden will be a repo, the base image will be a repo, and the product image will be another repo. And we will use GitHub Actions because we are using GitHub. So we are placing in the GitHub. We are using the GitHub Action as function. So with arguments and values. So we have a contract where I say, okay, for build, this is the inputs that we receive, and this is the values that I expect. What you do internally, I don't care, because this concerns the self-contained inside of in that component dash function. We use Packer to build image. So Packer has inference code and many other features that is nice to use to build different cloud providers. And we use Terraform to deploy because we need to build and test. So we need to deploy the machine and everything that's around of the machine, the environment that's necessary to test the VM. And also we use Ansible to build, to run some command lines to build, and also to test. So we want to test if something is working properly inside the machines. We use Ansible to test. And we need to use regression test strategy. So every time that you change a critical part of the infra code in any part of the stage, we need to run a full regression test. So if we change one line, one script that's shared in the hardened image, we need to test then the build, then we test the building base, and we test the building product, and we test the deployment and everything. And if everything's fine, yes, then we are saying that is safe, that our build is okay, and we can merge that code without any problem. So that's how we structure the project. So we have 4 different repos, one for each stage build. So harden, product base, and the product itself, and a tester repo where we have sanity test, integration test, performance test, soaking test, vulnerabilities scans test, Anything that concerns to different stage of testing, we are placing this repo, and we are calling from the other build repos those tests in a cross pipeline strategy. So the builder suite structure has a similar folder and structure across all repos. So it's easier to maintain. So the developer, when reads the repo, the code, will see, okay, yes, similar. It's a bit different because the context is different. When you're building a harden, it will be different from building a product. But the structure is similar. So it's easier to maintain. If you know how to maintain one repo, you know how to maintain the other repos. So we use reusable workflows from GitHub. So then we use composite actions, like it's a components, it's functions in high level term that allow us to use inputs and outputs and do self-contained logic in each cloud. So if it needs to get some secrets, some specific configuration for that cloud, we don't care because it's self-contained. We just pass what we need to do, like build with that version, with those parameters, and give me an image with some name. And I get this and will be used in the reusable workflows. Ansible files are used to build. So we use playbook with some roles and some tests that give us the freedom to install, to configure the VM as we want with those Ansible tests. It's very easy to provide the deployment. And we use Packer script to build the cloud image. So is multi-cloud supported, is infra as a code. So it also is a stack that we use. So the file dependency is how we manage the pinned version. So we use pinned version across all the repos. So that this way, when we are changing something, it will be committed, will be reviewed in the code review, in the PR. So we know exactly what will be changed. And then we can track back in the by the commit hash when was made some change and how some bug was injected. So we can trace back and find the bug and fix the bug very fast. And the test suite structure, we have a similar structure from the build. But instead of Packer, we use Terraform. So we use Terraform to deploy the VM and the environment around any resource that's necessary to deploy in that cloud. And also we use common Ansible files. So in this case, we don't use to the provisioning the VM, but we use to run some tests. So every test uh, in the Ansible roles are one type of test. So for example, let's assume that our product needs to create some files and some folders. And we need to guarantee that those files and folders are in place inside the machine because it's critical for the running software. So one type of test, for example, could be um, a test that goes and make a SSH to the machine, check if the file and the folder exist, and check if the file has the format and the content expected to be executed with success. So if everything's fine, so the Ansible test will run with success. If something is wrong, we ignore, so we place ignore the errors, and later when everything is executed, we summarize all success and error or ignore test, and we say, okay, we have some tests that we ignore because they are errors. That means we run all tests, but we place as failure because we should not ignore anything because that means we have a failed case. So that's how we use this strategy to build and test. But why this step? So I just give a hint why, but let's go deeper and check some nice features on, for example, GitHub. So because we use GitHub as the repo, was very natural to use GitHub Action because it has seamless integration. You don't need to use external CI/CD like Jenkins or another type of CI/CD that's common used in the for the community. But we choose GitHub Action for because that has efficient CI/CD pipelines. You can customize because it's made in YAML file, is human readable. The developers can easily to extend or create nice features. You can create the whole end-to-end automation, so you can build, you can test, you can deploy everything in one place. You don't need to build in one place, then you have to test in another place, and you have to deploy in a third place. So that is very handy and covers many aspects of the software delivery life cycle, development life cycle. So that is why we choose the GitHub Action. And why Terraform? We choose Terraform because it's infra as a code. So we can define the infra with code in a very constant way. So we can see, so if we need to change something that we deploy the infra, we can use that to always have the same state we desire in that cloud. Because we need to support different clouds, on-prem and also public clouds. Terraform supports that. You can even create your own provider if your environment is not supported officially by community or for the Hashcock. So that's how you can use Terraform. And has resource graphs. That means it will create in the order that makes sense and that makes your environment work. So if you need to deploy the VM and then after the VM you need to run some scripts that will call standard APIs to make some registering, for example, you can decide this order. You can place this to use some depends on properties that will run one after another and guarantee that everything will work as should. You can reuse components. So, for example, if you need to register something in all builds for all clouds, so you can create a register module and reuse this across the different clouds. So that's you reduce the copy paste script. You have a state management file. So because we built in one job, we deploy another job, and this deployment can run for after minutes. You can want to run for a few hours, or even you want to leave the machine there for a few days for some longevity test. We want to have the build, the test, and the tear down in different jobs, and they are in different individually. They are not they are no dependency. But when we need to have to destroy, we need to know what we are destroying. So that's why we need to have a state to know what we need to destroy. So that's why we use Terraform, because it's easier. We just have to pass, okay, this is the file. Please make a tear down of this file that has everything that you need to know about what was deployed in AWS or in Azure in any other cloud. And let's assume that the deployment didn't occur with success. So something was deployed and something didn't deploy. So you need to make a cleanup. So because the Terraform has a state of what was deployed and what was not deployed, so you have, okay, make a cleanup that will destroy everything that was created, and you have a clean lab. So you're not leaving anything behind on the lab. So it's good to reduce any trash, anything that should be deleted. And has many integrations with the community X system. Packer. So why you choose Packer? Packer is very quickly to build image with parallelization. So that's why we want to build very fast, and we want to build with parallelization, um, different clouds and different types of goods. And we want to support different platforms as we already see. So we want to support where the customer is. So we need to build for different platforms. And we have also the seamless integration. So we can integrate with all the tools. We want to have security. So we want to use from trust source that also Packer supports. And we use different plugins. And the plugins are the different plugins wide supported for the community. So that's also a nice feature. And as Terraform is infra. And why immutable infra for building image? At least for the product, we have a mandatory reason that we need from the same inputs, the same files, and we need to generate the same output. So that's why we are using pin versions, we are using if as a code, because we can guarantee that that same commit will generate the same result over and over. So this guarantee trust for some audit or anything that we need to guarantee that okay, yeah, we can that what your this binary, this image is this code, and you can guarantee that because if you build, you have the same output. And the Ansible, why use the Ansible? Because it's agentless, so we don't need to install anything in the product to guarantee that we can test or we can build. So we just use over SSH, and very simple. So we can run commands as doing SSH in command line manually, but via automated and programmatic code. Is using YAML file as well, and as GitHub action is human readable. So you can read, it's easier to understand and it's easier to change. The documentation is a good documentation, has many plugins. So if you want to use third-party plugins, for example, you want to use AWS native way from Ansible instead to call AWS CLI, you can use the plugin for AWS. So, it has different plugins. And you can predict the automation. So it's like potent. So, and also the community is very wide and has different plugins that you can install using Galaxy repository. And let's talk about the workflows. So here we have the build pipeline workflow. So we have the hardening image where we call when we change the code, this will create the hardened image, and then we use as input to create the product, and the product will be used to create the product image with the WEF security boot or the WEF without security boot for debugging for this example. So now imagine that we need to support AWS, Azure, and any other clouds and increasing. So this is our case, right? So, and then for each one, we need to run tests. So we need to deploy the infra, we need to run the test, and we need to tear down the infra as well. So here is how will be look like the full pipeline. So there one orchestrator that will know what to trigger uh, the builds, the harden. Then for each hardened image in each cloud, we'll create a product-based image, and then we'll create the product image with the proper boot mode. And for each image that was product image that was created, was built, we trigger a deploy, a sanity test, and then a tear down machine. So how we can make this, to guarantee regression tests in this case, in this scenario. So I will give you here an example about one user changed as shared the Ansible test in the hardened suite via PR. So he's adding a new security check or a security configuration in the hardened. And this may affect the whole chain, right? Because you're adding something that will change the OS, that will may affect the base image, that may affect also the product, that also will affect the product itself and affecting the test. So we need to guarantee that any change in any stage is fully tested. So in this case, we are building a temporary hardened image. Then with this temporary hardened image, we use as an input to create the temporary basic product. Then we use the result of that to create a temporary product. Then for each security boot, then we deploy that temporary product. Then we run the test and tear down. So if everything is passing in all clouds, in all security boot modes that was affected by this change, then we are fine to merge. Then we merge. Once it's merged, it will create automatically a PR with the new latest. We build a final hardened image. Then we will create a PR with the latest build of this harden to base OS. Then same thing, because you create a new version, you need to check if everything is still working. Because in the base image, we are not having everything pinned. We run some OS upgrades, software upgrades, like we need to update the Python, we need to run Ubuntu updates or something like that. That is not possible to pin unless we have cache. So in that case, so that's why every time that you build a final hardened image, we create a PR, then the PR we run the regression test to guarantee if everything's working. Then when the regression test is passed, we merge. Then we create a final base image. Same thing, we create a PR to the product and guarantee that everything is fine. But because the product image, we are not running anything that is OSP grades. We are pinning everything, the base image, the Cisco proprietary code, and all versions are pinned because we need to reproduce all over again the same build. We don't need to run regression tests in the PR. When you create a PR with the new versions, you are already creating a build. We'll see later a bit more on that. So see about the promotion test I was saying. So we create a PR, change the version of the base OS, or the version of the AnyConnect, or anything that is of the Cisco proprietary code that we have in different repos that create binaries and other versions. Then, with this file, change it, we'll see, okay, I change it for all, this change will affect all clouds and all security boot mode, or we'll change only one specific boot mode and one specific cloud. So based on the permutation of the change that you made, the pipeline will run a script that will identify which pipeline should execute. It should execute all pipelines for all clouds or only for one specific boot mode and one specific cloud, or a subset of clouds, and so on. Then this will create a real product image. Then with this image we deploy, we run the test, we run tear down, so we guarantee that it's fine, it's working. Once we merge, that image created in the PR will be used for further testing. Soaking tests, we are going to scan for vulnerabilities, CVs, and other stuff. And we run performance longevity tests, and then we are placing stage for a few days, where we are running other kind of manual tests and other stuff that we guarantee that we are everything's fine. We run against the provider scans vulnerability and other testing as well. And then when we are ready, for GA. It's not necessary that we are going to deploy that, we're going to deliver that, but it's just that it's already. So if you want to deliver a new version, it's ready. We just have to write the change logs to the customer that say, okay, what we are changing and why we're changing, and then it's ready to be on the marketplaces all over the clouds. So that's how we can have end-to-end from one image to the marketplace. So, and that builds. So we also need to guarantee productivity and facilitate the life of developers. So they don't need to have a toil of tasks to get some buildings and some machines. In this case, here, for example, a user wants to place some permutation of real versions or dev versions of everything, and then create an image using this as input. Then this dev build, developer can run some testing, something that in the dev cycle before to place in the code in the repository. So it's still running some dev dev code or something that is still not mature to be merged to main. But you need some results, some product that you can test, that you can deploy, and you can make troubleshooting or some analysis on the dev side. Another case is where you have an image, can be the image that we built in the previous step, or a real image that we want to run manual tests. For example, you are changing the ansible test. You are adding new cases, new cases to guarantee more coverage in the test. So this change the code. So if you commit and push, it will trigger the regression test for all clouds. But it's not very I'd say effective, because if you have a bug, you have to push over and over. So this will, create and destroy, create and destroy. Will take some time, and the feedback loop is not very fast. So it will be a time-consuming task. One way is to use deployment. So you choose exactly which version that you want to deploy, and you deploy, we create the environment, and you have the ephemeral SSH access for the time that you decide. I need 1 hour deployment. I need 1 day. So the developer decide how much time he needs, and after that, automatically you turn up. And during this access, you can make troubleshooting, or you can also run Ansible playbook. So you change the playbook manually in your code. You don't need to push. You don't need to commit. You just run, and you see the results. Okay, it's working. Okay, now I can push. No, it's still not working. I have a typo. I have a bug. So you can just fix in the code and run again the playbook. Fix the code and run again the code. So it's very fast feedback. Very handy to developers, these features that we have in our CI. So about the code sample. So I have some here, some screenshots, how we organize the repo. So you can see here our repo. So we, in the first column is the build. So where we have, this is how it look like repo structure with the GitHub folder with the actions and the workflows, the Ansible, the Packer, where we have a Packer script per boot mode. So that's how we can know, okay, for security boot, we need a inference code in one way. For BIOS, we need another way. For TPM, we need another way. So this is just a sample how you could, how we can have different cloud providers building using Packer. And for the testing, we has also similar structure. As you can see, actions. Then inside the actions, we have Ansible test. That is action, setup, and teardown. So why 3? Because we want to have separated components that we can use in different times. So I want to set up, only set up. I want to run the Ansible testing another time, and I want to destroy something. That's why it's 3 different components, and why is split in different clouds. So when we need to deploy for AWS, we need to know exactly the conditionals, this subnet, VPC, and other specificities from the AWS. For Azure, same thing. So we need to know the subscription, group, research group, and other stuff. For Azure, we need to know where is the lab, what is the VM as pure credential. So this is self-contained. So this does concern to outside of the component. So that's we have this self-contained action. And then we have the workflows. Same thing, that these workflows we'll call the composite actions based in the what we are building. And as you can see, this we have also a callable plugin. So this is how we have the testing I mentioned before, where we collect all state from the Ansible, and then we check what was passing, what was not passing, and then we break the pipeline or not based on the how many tests was passed. Um, a bit of the composite action. So for those that don't know the composite actions, this looks like more or less a composite action. You have a name, you have a description, you have inputs and outputs. So the inputs, that's how you call, you pass, and then you have outputs, what to expect after you call this composite. And you using the runs, using composite, this is the syntax. So if you want to know more about the syntax, I recommend you to go to the GitHub documentation. It's well documented and very simple to implement. Has some very nice examples how to implement, and you can use the GitHub SAS to test by yourself. Here in the second column, we have a step. So the composite is a grouping of steps. Any step is basically one command or group of commands that you run inside of your CI. So in this case, the packer, we are calling the initializing packer, we are validating, and then we are building the machine for AWS, AMI, right? So that's how we build for an image. In this case, could be instead AMI, could be the security boot that we are saying. So, and we receive the security boot as the input. So we could make this as customized. So instead to be hard coded, the AMI could be the security boot. In this case, as from the base or the seed, because the base seed has no security boot. So that's why I placed this example. The reusable workflow. So the reusable workflow. So workflow is basically a script where you have jobs, and each job has steps or groups of steps that you can have many composite actions, or you can have specify the steps directly in the jobs. And you can have many jobs in the same workflow. So in this case, we have we have a reusable build pipeline where we have one job that is the build that will generate one contract to call the composite action, as we can see in the last line, the second column, where you say, okay, this is the platform, and this is the tag, the version of the code from the infra I want to use, and here is my inputs. The version and this version is this. So with those inputs, the composite will know how to handle these informations and build a base image from the seed and the version that we want to use, the version that we want to use as the suffix version. How we call this reusable workflow, right? So we have another workflow that is executed by PR changes. And then this workflow has different jobs. So it has a job to generate the jobs, to know so here we are saying, okay, I changed the spec file and compare with the spec file in the main. Give me the diff, and then based on that, we'll create a matrix of pipelines. And then based on the matrix, we'll call the job. So the workflow has this static name of jobs. So we know pipeline, AWS BIOS, pipeline, AWS with security boot. So those are jobs in this workflow. We could use matrix that could generate automatically this script, but this doesn't work well, at least today, with a chain of pipelines, like a build that calls another build. So in the graph in the pipeline is not working well. It makes one unique block and you cannot see the flow. It's a bit hard to get. So it could be done automatically, but we decided to place hard-coded this block or this small piece of block to guarantee that we can see in the graph everything. And we will see later in another screenshot what I mean for this pipeline. In this slide, you can see. So we have a job that generates the pipeline. We have then, in this case, we are generating for everything. Then we generate for the base image, for AWS, for Azure, and for GitHub. And then the base image for AWS will generate for views and for security boot. And each one will generate um, uh, uh, a setup of the environment, then the test and tear down. And the Azure, in this case, only trigger the, in this case, very simple case, we are only supporting Azure BIOS and we are only supporting VMware BIOS. So just to show that we can have different numbers of security boot per cloud. And each one, after the base image was built, will trigger the following stage. Here, in the debug VM pipeline, we have example of how the developer can set up the machine, run, for example, for 1 hour, and after 1 hour, because we are using deploy environment rules from the GitHub native way, it automatically will wait for 1 hour, and then we will trigger the tear down. So you have 1 hour window to do whatever you want inside this machine. Then later you lose access and the machine will be destroyed together with everything that was deployed in the first job. Some crucial takeaways. So we learned that with this, the developers don't need to deploy the thermal iframe themselves. They just need to use, if they are using integration test, is done by the pipeline. If they need to do for some manual reasons, dev reasons, so they can deploy using just passing some parameters. So they pass what they want to use, and that will automatically deploy for them. The worst case scenario that we identified was 3 hours. So we changed the hardened and then we built everything and test. So it takes 3 hours. So if you identified a CVE in the hardened, in the or a problem, a security issue in the hardened, we can that will create the PRs, we merge, and then we have in 3 hours everything tested and working, ready to be patched to the marketplace if we need. We can add easily more providers without affecting the build and the testing time because they run in parallel, so they are not depending on each other. And because we are using infrastructure code principles along with the pinit versions, it allows us to find bugs faster. Because if we change something, one proprietary Cisco version, for example, and something start to break for some reason, we know, okay, that was working with that version, the new version is not working. So we identified what was the reason there after break. And the pipeline is modular. So the difference between the cloud providers don't are self-contained, so they don't affect the rest of the pipeline or outside of the components. Here I place some links where you can learn how to use this stack. I think this stack is pretty nice, so you can have very good get started. So if you want to have some similar implementations on your pipeline, you can start looking into these links to get some knowledge. And here are my social networks. So you can find me on LinkedIn. You can send me a DM and be happy to answer any question that you have from this talk, or if you want have more details how to about some implementations or any other subject, I'm happy to be answer your DM. And if you want to follow me on GitHub, here is my profile as well. So I appreciate your time to listening my presentation. I hope you have enjoyed this session and have a good conference as well.